everyone and welcome to Coderific. In this video, we are going to clear up a common misconception about the difference between machine learning and deep learning methods. If you have read other blogs or watched some videos, you might have heard that machine learning uses handcrafted features while deep learning does not. But guess what? That's actually not entirely true. Handcrafting features is optional in both approaches. What's important to know is that in both machine learning and deep learning, some form of pre-processing is almost always necessary to make your data compatible with your model. Whether you are cleaning data, normalizing it, or transforming it in some way, both approaches require that step. So, what's the real difference? It comes down to complexity. Machine learning models are often simpler, relying on algorithms like decision trees, k-nearest neighbors, or linear regression. These models are great for solving problems where the relationships between data points are not too complicated. However, they often need a helping hand with feature engineering. That means you might need to manually select or create features that help the model make better predictions. On the other hand, deep learning uses artificial neural networks, models designed to simulate how the human brain works. These models are much more complex and are capable of automatically discovering features from the data. While deep learning models can learn intricate patterns, they also require large amounts of data and computational power. The more complex the data, the more layers a deep learning model will need to process it. Let's break it down with an example. Assume we have data of housing and we want to predict square footage of a house based on input features like price, neighborhood quality, and the number of bedrooms. In machine learning, you would use a linear regression model. Mathematically, is represented as y hat ml is equal to theta of 0 plus theta of 1 x1 and so on. In this equation, y hat ml is the predicted square footage of the house. x1, x2, x3 represent the input features like house price, number of bedrooms. Theta of 0, theta of 1, theta of 2 up to n are the coefficients learned during training, which show how much each feature contributes to the prediction. This formula gives us a weighted sum of the input features, and the result is the predicted square footage of the house. Now, let's have a look at deep learning model, how we would perform a linear regression. In deep learning, we use a more complex model, typically a neural network. And here, the equation might look like this, where we have y hat dl that represents the predicted square footage. x1, x2 up to x of n are the input features just like in machine learning. w1, w2, wn are the weights connecting the input features to the neurons in the hidden layers. Sigma is the activation function which allows the neural network to learn non-linear relationships. And B is the bias term. In deep learning, the model processes these features through multiple layers, each applying a non-linear function to capture complex relationships. It is worth pointing out that in machine learning model, the coefficients would determine how much each of these features contributes to the prediction of square footage. But in the deep learning model, these relationships would be learned automatically by the neural network. So, in summary, the biggest difference between machine learning and deep learning is complexity. Machine learning models are simpler, work well on smaller datasets. Deep learning models, on the other hand, are more complex, capable of learning intricate patterns from larger datasets, and require much more computation power. Remember that both methods can use handcrafted features, but both also require data preprocessing. Ultimately, it's all about the complexity of the problem and how much data and computational power you have. Thank you so much for watching. If you found this explanation helpful, Don't forget to like and subscribe for more AI and data science insights.